In the last video we talked about finding the quadratic equation that went through 3 points. And you might be asking, is there ever an instance where I can find the quadratic giving only 2 points? And the answer is yes, but only if 1 point is the vertex. Okay? Otherwise you always need 3 points. Okay? So here we go. Give you an example. I'm going to tell you that the vertex of a parabola is at 114, and then a point on the parabola, another point, is 2, 10. Okay? And we're going to find the equation. That's our job. Okay, so here's what we do. If we know this is the vertex, we can write y equals a x minus 1 squared plus 14, right? Because the vertex form comes from the vertex of the parabola, and 114 translates to this. So now all we need to do, we're so close to the answer, is to find this. And the way we find a is we plug this value in for x and y. All right, so I'm going to rewrite this. I'm going to put 10 in for y, a stays a. I'm going to put 2 in for x, and then solve for a. All right, so I get 10 equals 2 minus 1 is 1 squared, so 1a plus 14, a equals -4. So the vertex form of my parabola is y equals -4, x minus 1 squared plus 14. And here's something we haven't done that we should probably do a couple of times, because you'll be asked to do this, is go from vertex form, change to standard form. Okay? And that just involves multiplying x minus 1, applying the square to it, and cleaning it up. So what we're going to do is, some people call that double distributive property, we call it FOIL in class. So here we go, y equals -4, and then I get x squared minus 2x plus 1. Don't forget the parentheses so that you hit each of them with a -4. So I get y equals -4 x squared minus 8x minus 4 plus 14. So final answer, this quadratic in standard form is y equals -4x squared minus 8x plus 10. Okay, and that's the answer. All right, so what we're going to do now is just do a recap on the forms of a parabola, forms of a quadratic equation that we're familiar with. There are 3, we've really only looked at 2. So the first one is the standard form. And what that's good for is telling you the direction of opening and the y-intercept. Ooh, I wrote y. I said y and I wrote y. That's not good. Bx plus c. So remember, a tells us the direction of opening and c is the y-intercept. The vertex form is y equals a x minus h parentheses squared plus k, where the vertex is hk, right? That's what that's good for. And then there's a third form, and it's called the factored form. And the factored form looks like this. Y equals a again, and then we have the quadratic factored, all right? And we know that whatever the x-intercepts are, and we're going to call them R1 and R2, we always put whatever the x-intercepts are, the binomial has the opposite sign, so x minus r1, x minus r2. So you might be wondering, if you know the 2 x-intercepts, is that enough to find the equation of the quadratic? And so for instance, if I know that a quadratic has x-intercepts of 4, 0, and -2, 0, can we turn that into a quadratic? And the answer is no, that's not enough, because I could come up with these 2 binomials, right? But I still don't know a. And so in order to find a, I have to know not only the 2 x-intercepts, but I also need to know a third point. So let's go ahead and finish this by saying the quadratic goes through 1, 27. And now we can solve for a by simply plugging the x and the y into this equation and solving for a. So here we go. Y is 27, a is a. In place of x, we're going to put 1, and in place of x, we're going to put 1. Okay, that's easy. So 27 equals a. Negative 3 times 2 is negative 1 minus 4, negative 3 times 3. That's good math. Negative 3 times 3 is negative 9, and so a turns out to be negative 3. So the factored form of the parabola that has the two x-intercepts of 4 and negative 2 and goes through 127 is y equals negative 3, x minus 4, x plus 2. Okay, there you go. Thanks for listening. See you in class. Let's say I gave you 3 points, and when you plotted them, you were able to connect them with a smooth curve that graphed a quadratic function that made the shape of a parabola. The question I have is, would you be able to come up with the equation of that parabola given the 3 points? The answer is yes, and when you find that equation, what you are accomplishing is this idea called curve fitting. All right, so the standard form of a quadratic equation is y equals ax squared plus bx plus c. And so our job is to take the following xy pairs, 1, 3, 3, 5, and 4, 9, and put them into this equation one at a time and solve for a, b, and c. And so the process of curve fitting involves a system of equations, and you remember that from algebra, I hope. But this time there will be 3 equations. So this might be something brand new to you. If not, I hope you do remember it. All right, so here's what we're going to do is one at a time we're going to put these ordered pairs in for the x and y, and then we'll combine them using some substitution and elimination and solve for a, b, and c. All right, so here is the first equation using the ordered pair 1, 3. So here's y equals a times 1 squared plus b times 1 plus c. The next one, 3, 5, will be 5 equals a times 3 squared plus b times 3 plus c. And then the last one, 4, 9, is a times 4 squared plus b times 4 plus c. All right, so system of equation involving 3 equations to solve for 3 variables. So first thing we want to do is we want to clean them up. So I'm going to go ahead and rewrite the first one as 3 equals a plus b plus c. The second one, 5 equals 9a plus 3b plus c. And the last one, 9 equals 16a plus 4b plus c. Okay, so our goal here is to get the variables to drop out. And so I think the easiest way, and there's more than one way to do this, but I think the easiest way recognizes that all 3 of them, the c, the coefficient of the c is 1. And so those will be the easiest ones to get rid of first. So the first thing I'm going to do is combine the first 2 equations only. And by subtracting, I'm going to make the c's disappear. So I'm going to look at 3 equals a plus b plus c, and 5 equals 9a plus 3b plus c, and I'm going to put them together in such a way that I subtract. Okay? If you want to take the time to change all of the terms to the opposite and add, that's an acceptable way to do it, but I think that you'll be okay by subtracting. So here's what I've got. 3 minus 5 is negative 2. 1a minus 9a is negative 8a, and 1b minus 3b is negative 2b. Okay, so I'm going to hold on to that and go back and put the second and third equations together by subtracting them. 9a plus 3b plus c, and 9 equals 16a plus 4b plus c. So again, I'm going to subtract, and this time I get negative 4 equals negative 7a minus b. All right, so now I'm going to just bring this one over here, line it up. Negative 4 equals negative 7a minus b. And I hope that you recognize this as now simply equation with two equations with 2 variables, and we need to combine them so that either the a or the b drops out. And I hope that you can recognize that if you multiply through the second equation by 2, then let's go ahead and make it a negative 2. then the negative 2b and the positive 2b will cancel each other out. So multiplying through that one by negative 2, I get 8 equals 14 plus 2b. Right underneath that, I'm going to write negative 2 equals negative 8a minus 2b. That's just simply copying that first one down. And then sure enough, these are going to cancel. This time I'm adding the two equations together, and I get 6 equals 6a, and a turns out to be 1. Okay. Once you get the first variable, then it's just a process of substituting back into different forms of the equation and finding the other variables. All right, so I can put a either in, let's see, I can put it in here or I can put it in there. But I want to make sure I put it into the equation that has only two variables. If I put it back in here or here, I'll still have two variables left. So let's go ahead and look at the first equation, which is negative 2 equals negative 8 times 1 minus 2b. When I bring the negative 8 over, I get 6 equals negative 2b, and b turns out to be negative 3. So I'm almost done. I've got two of the variables. I just need to substitute the a and the b, and it doesn't matter. I can actually use any one of those three equations. So I'm going to go to the easiest one, the one on the top, which is 3 equals a plus b plus c. So 3 equals, here's a, here's b, and here's c. So when I move the negative 2 over, I get c equals 5. So to answer the question, I put it together. I say that if I were to graph the equation y equals 1x squared minus 3x plus 5, it would go through the ordered pairs 1, 3, 3, 5, and 4, 9. Okay, so that's today's lesson. We're going to practice this a lot in class until you get really comfortable with it. Great, thanks for listening.